In this video, I'm going to give you a simple example about how we can use the built-in tools in Python to write unit tests for your code. Hi, I'm Matthew Young. I'm a back-end software engineer, and on this channel, I cover software engineering, things like how to get started, computer science fundamentals, and in this video, we're going to be going over how to write unit tests for your code in Python. But not only that, we're also going to give you some examples about how you can implement them in your own work. So before we break out the code, we should fully understand what is a unit test. And a unit test focuses on one piece of code, a unit, if you will. And in its most simple form, we should be writing a unit test for a small function to make sure that it provides expected output for all the different scenarios that we can think of. This is compared to an integration test, which tests multiple units, multiple functions, if you will, of code, and making sure that they provide expected results when working together. Today, we're just going to be focusing on the unit tests. So without further ado, let's break out our code editor. Today, I'm going to be using Code Runner. For work, I normally use VS Code, but you can feel free to use whatever editor you are most comfortable with when you are writing in Python. So because the focus for today is the unit test and not the code itself, we're going to write a really simple function. It's just going to take in two numbers, number 1, number 2, and we are just going to add them together. That's all we're going to do, simple enough. Now, when we are testing this, there is a built-in module in Python called the Unittest module. This comes default, so you don't have to pip install this or anything. And we are going to import this module at the top of the file, import unit test. Cool. Now, what we are going to do is we are going to write a class method, and this class method is going to contain all of the tests that we want to write. So we'll call this test add, and what we need to do here is we need to inherit from a parent class from Unittest. It's going to be unittest.testCase. And what this parent method is going to do, parent class is going to do, is it's going to let our code know that we have unit tests within this class that need to be run. Specifically, it's going to know that it's a unit test if it begins with the word test. So we can write define test underscore add. We need to put self in there because it is a class method. But because we have this test in here, we know that it's going to find our tests. So, the test, and on top of that, we have the parent method. So we can write something really simple now. We can just do an assert statement. We can say that if we add 1 and 2 together, that should equal the number 3. But if we run this, we will see that we get no output. And that is because we need one more line. We need this unittest.main function, and this is going to run our tests for us. So we run this. It says ran 1 test. It was successful, our test passed, 1 plus 2 does equal 3. And at this point, we officially have a functional unit test. We have done it, but we want to make sure that it's testing the right thing. So let's just break our test. 1 plus 2 doesn't equal 4, right? This should throw an error, and it does. It gives us an assertion error because 1 plus 2 does not equal 4. It does indeed equal 3. Now, to go back and prove my point about that parent class thing, right? If we were to not inherit this parent class, what would happen is it would run 0 tests because it can't find any tests. It doesn't know where to look. It doesn't know if there are any tests within our code. And this is bad, right? One of our tests is actually failing. It should be yelling at us. It should be saying, hey, you have broken code, but we don't have that. So we're going to put that back. We get that error again. And then likewise, remember we need that test in the beginning. So if we take away test, and you don't need the underscore, but it makes it more legible. So we take test away, we run it again. Same thing, 0 tests. It didn't know what to find because we didn't follow the procedure that the unit test module has laid out for us. So we need those two things. We need the parent class and we need test in the beginning. Now, one more thing to note, we fix this test, we get 1 test. The number of tests that it says it finds is not the number of assert statements, but rather the number of class methods. So if we were to say assert 2 plus 3 equals 5, it's still only going to say that it's running 1 test. And that's because there's only 1 class method. If we want it to count the number of assert statements we were doing for whatever reason, we would need to do another class method. So we could do test add 2, run this, and now it will say ran 2 tests. And if you've made it this far into the video, please smash that like button, drop a comment, subscribe. It really does help my channel immensely. Now, the last thing we're going to do is we are going to go over some examples about how we can implement this in our work, right? It's like one thing to look at like a very simple add function, but what's something a little more complex maybe? So on my GitHub, I wrote a quicksort algorithm, which basically just takes in an array of numbers and returns that list of numbers in ascending order, sorted order, right? And what I did, you can ignore all the code, but at the bottom here, I have this test quicksort class method right here, right? We inherit from our unittest.testCase parent class, and then we have our test class method in here. And I have 5 assert statements. And remember, we want to, if we go back to the definition of a unit test, what we ideally want it to be, we want to make sure that we're getting expected output in every scenario that we can think of. So I thought of a couple of different scenarios here. I came up with, the generic, like we have a couple numbers that are out of order, sort it. I thought of an already sorted array. We want to make sure that it doesn't mess it up. I thought of an array with only one element, an empty array, something with no numbers in it. And I thought of a large array, so 10,000 numbers in this array. You can probably think of more. Depending on the data structure that you're working with, you're going to get different edge cases, right? Like with arrays, you could have nothing in your array, but you could also compare that to a string. You could have an empty string, no letters in it, so on and so forth. Just if you were to have a graph, you could have no nodes in your graph, but you get the point. It's going to depend on the data structure that you have. And then the other place that might be applicable for you to write unit tests is in Leak code. If you come over here, before you submit your code, there's this test case tab right here. And there's almost always going to be, I think always actually, going to be one unit test that comes with a given problem. But if you want to make sure that your code is passing for edge cases, right? We thought of like the empty array. We thought of the massive array in the quicksort algorithm. We might add our own unit tests, or maybe if there are multiple examples here, we could copy these over, 3, 2, 4, 6, and we could make sure that we're passing all of the example cases all in one go. So we see here that we had 3 different inputs in there, and we get 3 different outputs, and this all passes. When you are passing all of the different edge cases that you test for, you can feel a lot more confident in submitting your code instead of submitting it and seeing that you failed and maybe not quite understanding why, right? It's a lot better to think through it beforehand than to see it fail and have to figure out why did it fail. And that's it. That's everything, guys. So smash that like button, and I will see you in the next one.